What is up, everyone? In this video is basically is going to be a Patreon video, but I'm willing to, from time to time, I'm sharing my Patreon teachings, approaches, videos also on YouTube to do some marketing, right? So you have a clue how it is on Patreon. Well, this is going to be some kind of a Patreon video. What I do a lot of the time is just coding stuff for myself or coding stuff for any kind of project I'm doing, and I just record it with my thinking process, and for you to learn something from it, right? And today, but of course, before we continue, if you not subscribed yet to my channel, please consider subscribing. Give me a thumbs up, leave some questions in the comments, jump into my Discord community, and of course, check out the Patreon. Every video has 30 seconds preview, so you can check if that's something for you, right? What am I doing? So for a lot of people know that I'm already building a very, very fast, low latency actor framework in Golang, which is called Hollywood. And of course, I'm continuously improving the speed. And today I'm basically experimenting with what is called the LMAX disruptor. And the LMAX disruptor is basically written originally in Java. Look it up, what it actually does. It's basically a very fast, low latency messaging queue. It uses other synchronization techniques than mutexes and channels and something. It uses, you also have a barrier, which basically means that you can divide your consumer groups on different threads and everything to make sure everything is like nanoseconds fast without any mutex, any lock, and any other crazy bottleneck, right? Bottleneck. We don't want that. So I have found this library. Actually, let me quickly show this disruptor here. I already basically forked it because it's already 4 years since there is a commit. So I basically forked it, and I could do some PRs and everything. But the problem is, it's not going to be merged within two. It's not going to be merged directly. So I basically forked it. But it's basically originally made by, not quite sure, Jonathan Oliver, I think. Michael Watcott, and Peter Kermihus has made a port of the LMAX disruptor into the Go programming language. That's it. If it's completely safe to use right now, not quite sure. That's why I'm experimenting and trying to see where I can put some stuff so it's actually super safe and super fast, right? So that's what I'm doing. So basically, I used before I was doing my benchmarks, I was using channels in Go, right? Go channels, but the problem is Go channels are fucking slow, right? They are slow, of course. In the most use cases, Go channels are good, right? They are easy, they are safe, they use, you can do whatever you want with it. They don't break, basically. But in this active framework I'm building, I want to be the fastest on the fucking planet, especially in Golang. So I cannot use channels anymore, right? Channels was good for the time it lasted, but not anymore. So I'm using the LMAX, and I'm making basically, you can see actually in my process, let me open it up. Process like this. I was using this inbox, which is a channel of envelope, right? And now I have an inbox new, which is going to be an inbox, which is this. So why I'm doing this inbox new thing, that's something I do a lot of the time when I'm refactoring, and it's maybe a tip for you, is do not delete everything you have directly before and implement the new stuff, because you never know. So I'm basically have this inbox new, and instead of, if a process want to send a message, right, instead of placing this into the channel, writing into the channel, I'm going to send to the inbox new, right? Which is basically here, this inbox. It has a ring buffer, which is a pre-allocated ring buffer of envelope. We have the disruptor. We have a receiver and a context, which I'm not quite sure what I need to do with this. It was just for testing things out. And then we have a consume loop here, which will access our ring buffer and all that stuff. And here we can send. We're going to reserve, which is basically reserve the sequence. We're going to read from the ring buffer, and then we're going to commit, right? That's what we're going to do. All right. So, and I already made some small benchmarks, and I'm already 2 times faster, double the speed than a channel, which is insane. I'm having 50 nanosecond latency right now, which is It's complete crazy, right? Okay, so the problem is actually, what I want to do right now is some experimentation and see if I can actually implement it in a good way, right? Because look at this, right? Look at this function. This is process start, right? And if I return, comment this in, of out, whatever you want to say it, we have this big loop, which is basically, which is going to recover if our process is panicking. We're going to recover, supervisor will restart that stuff. Then we have this loop, and this is basically our our main loop, right? Which will do a for select on the channel and does some, if we need to quit, we're gonna close the channel and all that stuff, break the loop, clean everything up and call it a day. But right now, we are in problem, right? Because this channel is not getting used anymore. So what I'm gonna do is I'm gonna return the pit here. I'm gonna keep this code in, very important. I'm gonna keep this code in, I'm gonna comment it out. So if we start, let me recap here real quick. We're gonna make a new producer, that's fine. We're gonna set the receiver and the context to this inbox new, and I'm not quite sure if I like that. The problem is, what I wanna do basically is, I wanna call something like p inbox new, run or something, right? Which will basically block here until it's done. The problem is that I cannot do this because this consume loop is a callback from the disruptor. And the cool stuff is that this disruptor is going to, let me open up this test real quick. If I run this test, you can see that it runs. If you see this consume loop, right? Each time it's going to consume, it's going to process some messages in batches. And that's why I made this print statement here to check, because I was not sure. Right, so we have 2 messages here, done consuming. Then we're going to read all these messages here, done consuming. So it's a very, very optimized thing. Wasting your time a little bit with some coffee. But these Patreon videos are much more relaxed than YouTube. Because in YouTube, the problem is people have an attention span of a goldfish and they want to see direct dopamine and they don't want to enjoy the experience of doing complex things, right? And learning these in-depth techniques and stuff, right? A lot of people don't understand what's going on, but that's because you don't watch these things, right? You know what I mean? Okay, so it's just another episode of The Walking Dead. You need to think about it like that, right? So what I'm going to do is I'm going to check in process real quick how I can fix this. In an ideal scenario, what I do is this, right? I set the context message as a message. And then I'm going to receive from the receiver in the consume loop. Which basically means that so this is, I make a new engine here, test inbox proc. It's basically just some garbage test I use to see if things actually do what it needs to do. So we spawn basically an anonymous actor in the engine. We gonna, if we have default, it's basically gonna say received message just like this. Let's see what's going on here. Run. Yeah, okay, so we see we have everything here. It's perfectly fine. There's also no race conditions, very important. And we send here, that's perfectly fine. Can I do a go func here? Normally it should be fine. I'm just gonna do it like this because I want to send in another go routine to check if there is any race condition, and there could be, because I need to do, I don't know, we will see. No, it's fine. One go routine is fine, so that's actually good news, very good news. That's already one thing. And how I test if I have race conditions is basically what you could do in VS Code is go test flags, have the race dash race thingy, right? Because if I make test with my make file, I can specify dash race all the time, dash erase all the time. But if you're using VS Code and you want to press these buttons here, you're basically not spinning up the race detector. So hey, if you want to do that, open up your settings, go test flags, dash race, and you're good to go. One important thing, it's going to be so hard, guys. This is also, for me, this is very hard, right? To see, this is not easy stuff. This is not your to-do list, right? What is this? Process go this read. Yeah, this is important because this is going to block. This is a blocking call. This disruptor reader read. I don't think I wanna call it here. So we make a new inbox with the option inbox size. We make a new disruptor, yada yada here. Inbox disruptor is this, that's fine. Then we have this process. We make a new, this is this inbox. Maybe we need to have the disruptor in our process. Because these quit channels, they're actually gonna be removed very soon. So I'm gonna say the disruptor. This, I need to sneeze. Oh man. Oh, god damn it. Don't look in the light. Don't do it. All right, we're good. I'm so sorry. Disruptor. It's going to be disruptor. This, as for some reason, I have a problem typing disruptor. It's a word. It's a sequence of letters I'm not used to. That's this. So what we're going to do, we make this disruptor here. So we're going to say disruptor is going to be this. We're going to put it into the process. Why? Because if we start here, we're going to make this. Make the producer first. And that basically means that we're gonna set the receiver here, and we're also going to do the initialized phase of our actor, right? If you spin up an actor, here is this initialize, right? This is this constructor, this producer func. It's going to produce your actor. It's going to call basically new foo, new bar, new Bas, new James, new Rick Morris, something like that. So we're gonna do the call initialized here. That basically means I'm gonna apply the middleware. Let me do a return pipit real quick. So I'm gonna see, what I wanna see is if I'm receiving, I should receive the initialize thing, right? Init. So that's fine. The only thing that happens is init. That's perfectly fine. So that basically means that each time we receive this init message, initialized message, which basically means you know, as a user of the framework, my process, my foo, just called new on himself, something like that, right? But then we also have a started, right? And a started is basically a message we need to send the moment we can actually start receiving messages. Because you need to understand that we are calling this initialized, we don't send a message to the inbox, we directly invoking the middleware with this initialized message. It's completely different. So the moment we start, that could be something like p disruptor reader reads, and that's gonna block, I guess. I think this is gonna block. My dog is doing strange stuff. I'm not quite sure what's going on. It's a beagle. He eats literally everything. That's the problem. You always have the stomach issues, right? Because he eats everything. He eats plastic. That mouses. This dog is legit. It's a raccoon. I don't think it's a beagle. It's a raccoon. He's eating everything he finds. It's crazy. And of course, with all logical, how do you say that? Problems after. So we're gonna apply the middleware. We're gonna disrupt the read. So I think here we're gonna block with this read. I think this read is gonna block. Let me see. Init. Wait. What's going on here? Why am I using my mouse so much? Am I turning into one of you guys? Let me see. Disruptor read. What is doing this thing? Let me do an fmt print line here. Println. Done. Calling read. Right. I don't have a debugger. Inbox test. I'm gonna do it like this. Fuck it. Use my mouse. Okay, we're blocking anyway. That's fine. I think we can call this, right? Println. Done. Calling read. Inbox test. Let's run this thing. Alright, we have a problem, that's fine. Don't calling read, invalid memory, yada yada. Context message, yeah, it's true, because we said don't set the context, it's all good. It's all good, no worries. So that's fine, we return the pit, that's all good. So what we also need to do when we start I'm gonna do something like this. Context, and we also need the receiver. Maybe we don't need that. I think it's gonna be context is fine. So we're gonna say p context receiver is this receiver. Then we're gonna do this apply middleware, all good. So this is disruptor reader read. So I don't like the way they do their namings, like reader read. It's reading, but it's actually just starting the disruptor. So, but I'm not gonna tinker around with this repository yet. I'm just gonna make sure it works first here. So this event stream is gonna be an activation event that we also need to send, right? So you need to understand everything below this return is gonna be legacy, right? Is legacy, old code. And now we're gonna make something else. So I'm basically yoinking code from below this to the top, right? From old to new, and see what we need and this what we don't need. So I've applied middleware here, that's fine. So when are we going to send this activation event? Which I think I'm gonna call a little bit different. Because I'm also gonna implement a cluster, and then cluster is gonna do some activations, and this is basically just an actor start event. So I'm not quite sure what I'm gonna do with this thing yet. So we're gonna start this disruptor, which basically means the moment we call a reader read, that's the moment we open up our ring buffer. That's the moment we open up I have a better idea, to be honest. I'm gonna not read here. We're gonna call here p inbox run. Gonna be inbox new, which I need to refactor later on. Run, and we're gonna run with the context. What's going on here? P context. That's what we're gonna call. Then we're gonna call the event stream publish activation event, and we're also going to join this started message. This is so dangerous. Wait, what I'm doing? I'm actually here, right? I'm gonna apply middleware. On the context. So we start the inbox here with the context, right? So we could do something like, we have this receiver, which we don't because we have the context here. That's fine. So this is going to be, I'm going to rename this to in actually. Actually, to be honest, I can do it with this, right? So this and then change symbol in. All good. It's going to be in context. Receiver dot receive. I don't like the way the context is implemented right now. I don't really like it, but yeah, it is what it is. So if we run, we're going to say that the in context is going to be C, and then we're going to say in disruptor reader read, something like that. So it's going to block here. So it's going to block on run. Maybe I need to do coding. Or actually I can call it like this and do the go here. I'm going to do a trace. Inbox. I don't know what the size is. Do I know what the size is? No clue. Doesn't matter. So I'm going to start the inbox. Set the context. The context of... yeah, there's a context. We don't need the context in process, I think. Or maybe. Because it's a pointer and we share that. Sharing pointers across objects is... sometimes it's nasty, right? Unless you know what you're doing. But it's easy to shoot yourself in the foot. So we set the context. We start the inbox. We gonna receive this message. And then we're going to... Because we first need to start the inbox. And then we can start, call the started message... Send the started message to our actors, receivers. And then we're gonna publish that it's activated. And... then we're gonna return the PID. Of course, I need to implement this max restart stuff, but it's not going to be in the process, I think. All right, so let's see what's going on. Inbox test. All right, so we have an init. You see how cool this is, right? You can already see what's going on. That's why these trace logs are so important, putting logs everywhere. And you could say, yeah, but logging it's cluttering up my screen. That's true, but you need to level your logs, right? I'm always using a trace. If you're not sure if it's maybe... this log is going to be an overhead, make it a trace, right? So you can see we init. Then we're going to say log trace, the inbox has started. And then we're going to call started. And then we're receiving all these messages in our receiver here, which is good. So that's working pretty fine. And you can already see if I want to do an engine test here. Let me benchmark message local. Let's bench this real quick. Look at... what the hell's going on here? This is not good. I don't know. We're gonna see what's going on because I'm fucking things up for sure, right? For sure. Test race thing. Where are we? Process. Run the mailbox with the context. We have the receiver in the context. The problem is that we also need to have some middleware here. That's also a fucking thing. Because middleware is not going to work here. Right? So we have some concept of middleware which you can use to apply some middleware to your messages, to your receivers. But because we are basically calling receive receive inside of consume. We don't have access to the opts middleware. So I need to check out how I need to find a way to do that. I did some tests yesterday and I had 50 NS, so I'm not quite sure why this is... Oh, I know why it is. It's this one. Of course, it's the race it's a race condition. Oopsie. Of course, it's going to be insane. Wait. Test center is probably borked. Cancel running test. What's going on? Wait, what's going on here? It's still early. Benchmark, this one, boom. Let's see. You see, 56 nanoseconds. Insane, right? The speed is crazy. This is crazy speed. We need to understand we're sending messages at the speed of light. This is low latency. This is... I'm gonna build a paper trading engine with this on stream or on video on YouTube soon. And I'm gonna use this low latency in Golang. Can you imagine? A channel, if I'm using a channel, you have 150, 120 nanoseconds. So this is basically 2 times, 3 times faster. Zero allocations also, of course, by the way. Hey, what did you expect? All right, that's good. That's what I want to see. The problem is this, I need to fix this middleware here. Right, so I'm going to say to do, what's going on here? Find a way to add middleware here. Yes, that's it. Okay, so now I need to find a way to stop it. We're already at 30 minutes, so I'm basically going to wrap this up. Actually, maybe some 5 minutes longer, right? 5 minutes longer, and I can drink coffee to provide some energy for 5 minutes. So, how are we going to stop this? Because stopping is with a poison pill, and a poison pill was basically a message we... Actually, to be honest, we're going to send poison pills, right? So what if we... We could use... I have the best idea. I am insane. What we're going to do is we're going to make 2 inboxes. We're going to make a user inbox and another inbox, a system inbox. And a system inbox can be with channels because it doesn't matter, right? Because it's going to look for system messages, for example, a poison pill. And if it's a poison pill, we can close the disruptor. So you see this read here, this go routine. If you want to close a reader, it's going to be in disruptor reader close, right? You see this? If it's going to close everything and it's going to completely shut down reading. So we need to call that. So what we could do here is this. A small loop For example, a small Go routine here, where we're gonna listen to what's going on here. Then we need this quit channel also. You know what? The next video, I'm gonna stop the video here. So for the people on YouTube, thanks for watching. Thanks for staying here for 30 minutes in this painful refactor, in this open heart surgery. If you like the videos I'm providing to you, please consider subscribing, give me a thumbs up, leave some questions in the comments, and jump into the Discord community. Like I said, this is most of the videos I'm providing, but of course in a longer format and in a sequence on Patreon. It's more of a developer experience, engineering experience on how I approach things and how I do real-time stuff, because I think it's going to be a little bit harder to follow maybe, but it's going to show you that coding is not making to-do lists and these simple APIs. If you want to be a backend engineer, you're gonna do from time to time very hard things, and that's what I wanna bring. So that the real life experience, the day in the life, right? The real day in the life. All right. Thanks for watching, and I see you in my next live stream or video. Bye bye.